heard some really interesting talks about how we can harvest energy from the environment and make sensors more low power. And then, as Colin was talking about, we're deploying nationwide IoT networks. So my first question would be, so how close are we to getting this energy harvesting, these very low power technologies into the Cellnex network out there? What do you think? Where are we in terms of that? How much more research is involved? Are there examples of products that are already getting out there? Yeah.
There are products. So as I was saying, there are currently a couple of companies that develop energy harvesters. They are multimodal and they are based on more resonator, so really a mass spring system. I think the problem is changing a bit the mindset. So to all the company, we talked also with Professor Punch. One of the main issues is that people don't see energy harvesting as reliable, so as a reliable source of energy compared to batteries. So they just keep preferring using the battery because they know that it won't run out of power. While if you plan your network well, you know more or less your environment, you can have an autonomous sensors that will be there for life.
Yeah. Okay.
Well, maybe just on a point on that. I mean, these sensors and even the gateways themselves are really low power. I mean, and that's the thing you got to remember. So it doesn't really take a huge amount to keep the power there if it is a sustainable source. So I think the challenge is probably not that difficult, probably medium to long term, to implement these types of solutions, both at the sensor side and perhaps at the network side as well in terms of the gateways. But the power consumption is actually very, very low. So I'm sure it probably is achievable, but obviously the research that's been done is really good. And it's interesting because the vibration part of it is, can be quite interesting as well, because one of the things we're trying to measure at the moment is vibration on the towers. So it was never really something that we thought about before. They say that the lifespan of infrastructure like that is 30, 40 years, but nobody's really ever monitored it in a way like that. But now we have a capability to monitor the vibration, and over time, if that vibration starts to increase, then you have a problem. But the vibration itself could be an opportunity to harvest. Yeah. So it all comes back full circle when you start to think about it.
And what about so great examples there in kind of an industrial environment, but what about out on the streets here? So we've got all these buses that are going by, the trains and so forth. Are people looking at harvesting energy from those vibrations as well?
From railways, so from trains.
Railways or buses, automotive?
There are projects going on to monitor both trains. So there are sensors put on railway tracks, but there are also sensors on bridges to monitor the structural health of the bridges itself.
Yeah.
So I think that the one Perpetuum
is the train one.
BB's in Southampton was one of the early successes because the deployments didn't have wired power. So you were deploying at two locations where you weren't, one, you didn't want to be gone out there with a battery, and two, you didn't have wired power. Yeah. And I think a key part to add to what Valeria and Colin were talking about is the idea of the power management. And this is where, when you've kind of got multimodal energy sources, particularly where you're not guaranteed, right, continuous energy supply, and then you're having a really efficient low power circuit with low wake up, right, and low quiescence, and that's the PMIC work that Mike Hayes And I think that'll really feed into the test bed as well, because like you were saying about the application spaces, once you show people what's available and what's out there, and you say, we're not stuck to solar, we can use solar and or thermoelectric and or vibrational, right? Then you really open people's imagination up. Because I think, as you say, part of it is constrained by the end user just not realizing that there is a technology out there that could be used to do it.
Yeah. And so we saw a nice example of I guess it was an IoT gateway that's being powered off of some solar panels, and maybe there was some wind on top that Cellnex had there. I've often heard if you go to a larger base station or something like that, you'd have to fill up a whole field, like a farm size, to power the actual base station if it's not a low power kind of thing. How close are we in terms of this sort of energy harvesting to be able to actually power gateways or base stations or things of the sort?
Okay, I think we have a bit of a different magnitude, like different orders of magnitude of power.
Yeah.
With energy harvesting, we are more looking at powering the node, the small sensor at the edge, more than trying to power the gateway. So the idea is that we are the gateway, it will be still like either connected to the mains or powered by renewable larger solar panels compared to what you might need for powering the small sensor.
I think on the network itself, and the IoT, the LoRa gateway itself is very low power. You're talking tens of watts, right? But if you go to the larger, what you're saying, the larger base stations for the mobile operator equipment base stations, it's much higher requirements in terms of power. But there's a lot of things happening in that space, you know, not necessarily in Ireland, but across Europe. I mean, some of the regions where there isn't a grid availability, they've had to come up with solutions for this. Islands out in the, you know, off the coast of, say, Australia, New Zealand, they've had to come up with solutions and deploy renewable energy sources. And it may mean that there's times when the network is down, so that you have the harvesting then to get it back up and running again. And that is a situation in some places where, you know, the island has to decide, do they want the connectivity for communications, or do they want it to power the light in the house? So, you know, they have choices. But I think the reality is that all of the networks, and we've a plan next year now to start looking at this in a real serious way, is to try and see how we can reduce the energy from the grid, so that it mightn't be replacing it entirely, but at least we start to reduce it. We do have sites now that have like the wind turbine on top of the tower. It's an ideal place to put it. Small 30 kilowatt. It won't take all of the energy off the grid, but it'll certainly reduce it. And then if you start putting panels there as well, you're getting more efficient. And as I said, you know, then the realization is, well, then we have an IoT network that we're able to monitor all these things and see how it's performing and what the real impact is. So I think there's certainly I think there's a change in that space coming, and it's been probably talked about for the last 10 years, to be honest. But I think it's really starting to happen now. And there has been, like, over the last 10 years that I've been involved in this industry, you know, it has been a discussion point. And I've been at various conferences outside of Ireland where it's coming up. But now it's a case people realize that they have to do it. They just have to do it. And I think I'd be very confident that we can sit here next year and I can tell you about what we've done as a company over the next 12 months, because, you know, if we decide to put the effort into it, you know, we'll certainly make it happen.
Yeah, great. We have questions from the audience.
We have questions from our online audience. Just bear with me one moment. So, question from anonymous attendee: with the COP26 meeting in Glasgow at the moment, how significant is the research we heard about today for making a meaningful impact on carbon emissions and the overall climate crisis? That's a challenging one.
I think you could start by saying you're building awareness. I mean, when you have an awareness of how much you're using, I mean, this is probably heard this time and again. You can ask people, you know, what their phone bill is, but they might know what their gas bill or their electricity bill is. You know, they know how much they're putting in the car every week, but they don't know how much they're using. And then this idea, you know, that was mentioned this morning of the monochrome, you know, internet, that once people begin to realize that taking a picture of your cat and sending it out to your 400 followers actually has an energy footprint, then that does become, so I think there's a personal awareness about it, and once you get personal awareness, you get ownership, and that's where the communication piece and the EPE piece is really critical, because, you know, it's just a personal opinion, but if you looked at Moore's law and ICT in the 20th century, it was all about do more, go faster, just make it faster, make it faster. And I've heard people say that the 21st century is all about lower power. Now that was to drive mobile, but now people are realizing the impact on the planet, and there'll probably be a twin track approach there. So, you know, you don't want to be charging your phone every 10 minutes, but likewise, you don't want a coal-fired power station. I mean, I heard a story, I don't know if it's anecdotal, of that at COP26, they had some electric vehicles, but they didn't have enough local power, so they had some diesel generators behind the wall charging the electric cars. And you could say the same thing in Ireland at the moment. I mean, Ireland is transitioning to that wind energy. So I think there's an individual level and a community level side to it. And certainly it's clear from what I've heard today that everybody is thinking about the energy. It's not everyone knows it's a finite resource, the material resources. So we can't not think about it. It's there. And
we should acknowledge that, so my understanding is that things like concrete production take up something like 50% of the global carbon emissions right now, right? And there are these big things that really take up a lot, but they're working on new types of concrete that'll actually absorb carbon, right? And so people are attacking those you know, major problem areas, and that's going to bring that down. And then suddenly ICT and the rest of it starts coming back up, right? And other things that we're doing in our lives in terms of knowing how we're using energy. If we can get that under control, we can't neglect that when you look at the carbon footprint as a whole. And as I mentioned in my talk, so we're something like 2% of the global, right? So you can say, well, why are you bothering? But again, everyone else is working on this. And there's a notion that, and I you know, this seems to be playing out accurately in all the scenarios that I've seen, is that ICT really does, and internet technologies in general really do allow us to be more efficient. Now, there's an argument that we start to produce more as we become more efficient, but that's where, again, policy comes in, and behaviors, and as we continue to bring this technology in and think about how we're using it and understand how we're using it, we can bring it under control. So it has to be a holistic approach at the end to make it happen, and I think the ICT is the tools to do that. Yeah. Was there a question over?
So, I mean, ICT systems are hardware and software systems. I mean, hardware and software works together. Otherwise, we wouldn't have them. And what I wonder is, are we doing enough in making sure that the two areas actually work well enough together to minimize energy consumption? Because to me, it seems sometimes is that the hardware side makes advances in trying to create lower power processing, for example, and so on. And then the software people say, hey, now, we can do more, rather than actually thinking a bit more holistically and trying to work together, because you can do a lot in the overall system, and like from a network system perspective, for example, you can do a lot to minimize overall power consumption also through clever software networking, for example. And I wonder, are we doing enough there? I don't get a warm feeling thinking about this, but maybe there are other opinions.
I mean, I've seen a little bit of that in terms of the issues around data centers, right? And microprocessors. And so people are thinking about how their software gets implemented in a processor and how they can make that more efficient. And then also with the data centers. And we've seen some scenarios talked about today and VMware and others, if we're deploying AI widely, so there's a large energy cost associated with that. How do we do that in a more efficient way? So I would agree with you that there needs to be tighter integration there. I think here in Ireland, we have a fantastic opportunity. For example, in the Enable projects or Connect, working with Lero and Insight, that are both bringing that intelligence and the software side of things, and we've got the hardware and the network part of it, that we can go after some of these types of approaches, and love to see that. Yeah.
Yeah, no, I think on the network side, certainly now it's a topic of discussion. I think the solutions are going to come. That's I'm talking about the front end, which is the hardware side. In terms of the back end, the software, I wouldn't be as familiar with the developments there, but it's certainly something that's very topical when you hear about data centers and the power consumption. So I think that's something that's going to have to be challenged and tackled. But definitely on the network side, on deployment, power is a big consideration now in terms of, when you're purchasing hardware, what's the power consumption? Can I reduce it? Can it be efficient? So it wasn't like that, say 10, 15 years ago. It was about getting networks rolled out and get them rolled out quickly, and that was really not something that was thought about. But I think over the last 10 years, there has been a lot more consideration being given to that, and there's advances being made in terms of the hardware technology is getting smaller, it's getting more efficient, and putting in more free air cooling systems to reduce air conditioning. All of these things are now being considered in the rollout on the network side. So the next step is to see how you can make it more sustainable and into the long term. I think that's where we need to go next.
I've got another 2 questions here.
Yeah, you're good.
So one of them is, can collaborative projects with Connect include the hiring of PhD students, and have many companies worked with you before? Absolutely they can, and in fact that's a significant part of the model, but it's essential to engage with us early in the 6-year cycle of the centre. So that's 2021, 2022. PhD studentship is 4 years. That can be financed, co-financed with industry. And we're actually measured on the departure of those PhD students into industry. So in a lot of cases, many of the PhD students who start with us end up in industry. And that's exactly what the model is. We've worked with 44 companies and organizations in the last 6 years. I have a second, more technical question. Would the rotational kinetic energy harvesting system, similar to that developed by the watchmaker Seiko, be potentially applicable in wearable IT devices? That's coming from Donald Kennedy at LED Group Robust Lighting.
I'm not. I know the rotational harvester from Seiko. I'm not 100% sure on how it works because it's kind of protected. But definitely, it can be used for powering wearable devices. I know that there is a group in ETH Zurich that is working closely with Seiko to use their rotational harvester to power wearable devices. So definitely it's possible to use it.
Other questions locally here?
Any other questions from the audience here?
So I want to talk about scale, right? So Aidan, you were bringing up the point about how, I had some numbers for estimate that Global Sustainability Initiative had for in 2030 where the total end user devices, their energy would be. And clearly if the RFID tags in Japan are taking up over 1% of that, we're going to be looking at a lot more than that, right, altogether. So I think these types of analyses, and as we scale up to very large numbers, are extremely valuable, right? So that we can get some reality checks on that. So I want to discuss that a little bit, and starting with, let's talk about cell sites. So with Cellnex, a lot of companies are talking about, or operators are talking about going to tens of thousands of sites. You're saying there's 2,000 in Ireland today. As you look ahead, what are we looking at in terms of small cell sites that around Ireland? Are we going to get to tens of thousands, 100,000?
It's a very good question, Dan. I started off my career in ESAT Digifone back in 96, 97. We launched a national GSM network with, I think it was 150 sites. Now, primary focus was we were trying to cover main cities, towns, and the national primary roads. That was the whole focus of launch. And, I think the networks today, each of the operators today would have somewhere between 2,500, 3,000 sites covering the country. So each of the operators have that type of footprint. We're managing nearly 2,000 sites as part of that. So some of those sites are shared with each of the parties. Some of them have only 1 or 2 operators on them. So that's kind of where we've come from in terms of the late 90s to today. So it's like over 25 years. And then it's what happens next? I think there'll be a consolidation. There is still an ongoing consolidation where sites are being consolidated together. That's been something that's been happening for the last 15 years. And that's a natural thing. So the number of sites will probably shrink a little bit, and then we're rolling out new sites. We're rolling out new sites where there isn't any coverage today. So, it depends. It depends on a number of things, I suppose. Number one, what are the obligations on the operators to cover rural parts of Ireland that aren't covered today? We've launched a Get Connected campaign, which is a public website. We've launched with that in the last couple of months in a couple of areas where we're allowing the community to put forward an application to have their community covered with mobile phone coverage. And that's been really interesting because some of the communities are coming forward saying, look, we don't have any coverage. We can't guarantee that we can do something. But the commitment we've given is that we will do everything we can and make every effort to try and make something happen. But we need the support of the industry. We need the support of potentially government in terms of funding. And we're really excited about it because we see really small communities, and like sometimes even just crossroads where there's a few houses. It could be a church, or it could be a pub, or it could be a shop, but they're congregation places where people come and things happen there. And it's only when you go there you see that there's actually a real need for connectivity. There's all of the rural hubs that are being rolled out at the moment, where the government are funding that. And again, some of those locations don't have connectivity, so they need to be covered. So you think about the number of sites. There are different types of sites. They're small. They're only covering small areas, and they can be both rural in nature, or if you go into the city, then you're talking about hotspots where you have high capacity, a lot of people, and there's where your densification and the small cells comes. Yeah. I don't see it being thousands of sites. I think we'll see a natural growth over the next, and we've been talking to DCC about this, like what happens in the city. It's probably more likely to be hundreds of sites as opposed to thousands in the next, say, probably 5 years. But then you could look at it different and say, well, can we get rid of maybe the bigger sites and bring it down to a low level and replace some of those bigger sites and make them smaller, less, more efficient in terms of power consumption. So there's opportunity there as well, but you're now replacing something that's there and you're putting something else in place. That could be more sites but to do the same thing.
And certainly we need the higher speed access will require the shorter distances from the cell location. So we need the higher density because of that alone, right? So.
And you need fiber connectivity as well. So you need to bring the fiber into the backhaul, and you need to bring the more density of the sites, the higher capacity and the speed. So, you know, there's lots of opportunity there. I think it's, you know, as I said, I've been through the GSM, 3G, 4G, and now we're into 5G, and it's happened in relatively small space of time, right?
Yeah.
And when you start thinking about the networks of the future and what do they look like, it's very different.
Yeah. So as we go to those higher densities, some of those energy studies that I was showing the results from, so those were from 2012, 2014 maybe. I haven't seen a lot of data for today's networks, and even looking forward. So and we've been talking with VMware, and they're interested in this and trying to get a handle on that. I think it's something that we need to do. It'd be really interesting to understand, and I'm curious, both Aidan and Valeria as well, if you think it'd be feasible to start thinking about if every light pole in Dublin and Cork are access points, right? You know, how much energy would that take? And then let's incorporate some energy harvesting from vibration and so forth. And not only that, so what sort of bandwidth can that support in terms of connectivity of things? So Aidan, you're talking about these billions of tags in Japan. So as we scale up these end user devices, is it enough even to have an access point on every light pole, or would that give us the capacity and so forth? And do we understand these things?
I'd say just from the kind of consumer perspective, it's important to understand what can be tolerated. I mean, there was an economic argument which meant that the plastic electronics never came to fruition, or the printed electronics never came to fruition with the RFID thing of Walmart 20 years ago. There's a kind of a societal drive from that METI project, just from the little bit I've seen of it. I've only seen bits and pieces in the last couple of months, even though it's been going back years. They've had a few demonstration activities, but I think the key part of it is in, if you look at what the EU is doing in Horizon Europe in terms of the Green Deal and a circular economy, it means you've got to have eco design right from the beginning. So it can't be somebody kind of pushing, saying, oh, we have this, you know. It's saying, well, what's the, and even in terms of the consumer electronics, where you see recent studies that say, okay, people are sort of greenwashing a little bit, saying, oh, the energy usage is this, and you're kind of going, well, that's the gate to the grave stage of the life cycle, or it's even the gate to just out the gate, right? They're not counting the material extraction and the processing costs as well. So I think I think that all needs to be done for specific applications. And the one around the RFID tags was interesting to me because it's nearly as simple as you can get. You can't get much simpler in terms of components. And what I'm taking from it is you're saying, look, if you're going to release that many of them, they have to be really, really simple. And that then determines, for particular technology embodiments, you're saying, okay, if we want to deploy something here and it needs an energy harvester, probably not going to be 100 billion of them. So how many do you need for a start? And how many, can you, even just looking at those numbers from the RFID tags, you're kind of going, there's a compelling argument there to reuse them, like you're going to reuse glass bottles or bottle tops, or, and there's a whole societal side of that as well. So I think the sort of disposable culture and the planned obsolescence is gradually going, and people are recognizing that isn't fit for purpose anymore. And the opportunity is to kind of lead and get ahead and go, we've done that full responsible life cycle assessment, and this one here isn't going to fly, and this one here has a chance. That would be, but I'm not a network person, I'm ashamed to say. I'm just thinking of the small little thing, the edge of the edge. So, but certainly it needs that holistic view, I think, all the way through the network, from the edge all the way in.
Very good.
Dirk, I think you have a question.
Yeah, I'm not sure whether it's a question or I'd just like to throw in some thought. And it brings it a little bit back to what Colin and what you said, Dan. So, I mean, we've been making great strides in being more power efficient for wearable battery-powered devices, for example. But, you know, we're talking also about data centers and so on. And to me, it seems that are we actually making the same strides on the side of computing, networking devices that are mains powered, where we assume, well, sure, we don't have to worry about it because they're mains powered, because electricity comes out of the plug and wall, doesn't it? And so I led I coordinated a European project a while ago where we looked at trying to make data centers more energy efficient. It was a FP7, tail end of FP7. It was a project looking at, can we power data centers with renewable energy? And so I remember we had the IBM Zurich lab was involved, and they looked at you know, how to consolidate server loads and things like this. And what we actually realized was that modern servers are actually not designed to be powered off frequently. So what we thought was, okay, maybe if we virtualize everything and we have compute and we consolidate virtual machines on a subset of the physical servers, couldn't we turn off those servers that we don't need? But they're actually not designed to do that, certainly not frequently. And so I wonder, is there potential there to actually, on the hardware side, on the design side of these systems, for us to do more? I'm not sure whether you have any answers to this. I'm just throwing this out just for all of us, maybe to.
No, well, I think that is part of it's part of the development on the network side, that when they're not using resources, that they close them down. Because you take a normal telecom site today, it's a pretty stable draw from the grid, whether it's busy or not. The draw is actually constant. But if you can start turning things off and reducing certain things that are running, then the power consumption will go down. And I think, you know, the stats are there. We know when the traffic is required and we know when it's not. And when everybody's gone to sleep, the networks, and certainly the mobile networks, they're not doing a whole lot. So there are opportunities, and I think in the latest technology advances, those types of features are actually built in. So I think that is already happening, certainly in what we're seeing on the new technology.
Yeah, historically, it wasn't just the servers and, well, telecom gear, but the power management systems of these data centers weren't meant to handle a varying load either, right? And I heard that it was similar for a lot of the base stations. Maybe you're saying now that they're starting to make the power more adaptive so that you could efficiently deliver at different loads. Yeah.
So could I maybe just throw something in there? So one of the technologies that we've been working on within Connect and outside it, which recently managed to get some awards, is this idea of magnetics on silicon. But the idea might address what you're talking about, Dirk, where instead of having all the power supplies outside of the microprocessor chip, you actually bring the power supplies into the microprocessor chip, and you divide them up into an array. So you almost create a nano grid of power supplies, DC-DC converters on the microprocessor. And now with microprocessors going, you know, 100 to 500 cores, and the voltages that they need, there could be maybe 20 to 50 different voltages. So it's really valuable if you could have that nano grid on the microprocessor controlling each one of those cores at the different voltages. You can actually save an enormous amount of energy. So in the technology that we've been looking at, it's going to end up in product shortly. And what they're saying is that they will get 50% more battery life out of the product by using that type of technology. Now, of course, everyone's going to use that energy still, but at least it's not being pulled off the grid. So I think the same could potentially be useful in that server scenario.
Yeah, that's a great point. And data centers today, if you talk to folks, it's all about cores. How many cores are you offering? And so to be able to control at the core level is even more valuable. Yeah.